This is Geometry Lesson 5.5, Special Parallelograms. We have three special parallelograms that we're going to be talking about. We have the rhombus, which we know means we have 4 congruent sides. We have the rectangle, which we should know means we have 4 congruent angles. And we have the square, which is like a rhombus and a rectangle put together. We have 4 congruent sides and 4 congruent angles. Let's go through all of these one at a time, and then we'll come back and add the shapes onto the drawings, onto the pictures. Rhombuses. The diagonals of a rhombus are blank, and they blank the angles of a rhombus. The diagonals of a rhombus are perpendicular. Remember, that means that they intersect at 90 degrees. And they bisect. The angles of the rhombus. I think I want one more here. They bisect each other. That's a O. Each other. And it moves too much. They bisect each other and the angles of the rhombus. Okay. In symbols, what that means is if we draw in our diagonals, right? B to D, A to C, they are perpendicular. There will always be that 90-degree intersection in the middle. Okay? They bisect each other, so this piece here and this piece here will be the same length. So if that entire diagonal was 10, we'd now have a 5 and 5. Same thing going the opposite direction. Let's pretend this whole thing was an 8, and now we'd have a 4 and 4. So they're always going to get cut in half, but mind that they're not the same, right? From A to C is a little longer than from B to D, but the halves are the same. And then they bisect the angles of the rhombus. So that is right here. This angle would be cut in half, and we do actually have the exact same set of angles on the other side. The corner at D is also cut in half, and we have the exact same relationship on the other side by B. Okay, all 4 of those pieces would be the same. Next, we have our rectangle. The diagonals of a rectangle are congruent. And bisect each other. So if I draw in this diagonal going from A to C, this diagonal going from B to D is the exact same length. And all of those half pieces are the same. So this piece, this piece, this piece, and this piece, all the same length. So we have kind of 4 halves that will all have the same value. And then for square, the diagonals of a square are blank, blank, and they blank. Now, because a square is like a rhombus and a rectangle put together, all of the things we've said for our first 2 special parallelograms are still the same. So the diagonals of a square are perpendicular. That means there's that 90-degree intersection in the center. And I'm going to just squeeze him in here. 90 degrees. Okay. They are congruent. That means going from one corner to the other will be the same distance if we do the opposite corners. They bisect each other. And the angles. Now, all that going into symbols, I'm going to scroll back up, try to get my square on there, means that if we connect A to C and B to D, we will notice that the center will always be a 90-degree intersection. The halves here, from A to the center, B to the center, C to the center, D to the center, all 4 of those pieces are congruent. And then if we look at the corners, the original corners are all 90s, but they're all bisected. So then each of the little pieces that are left over are all going to be 45s. Half of 90 is 45. So every one of these, 45, 45, 45. I'm not going to write them all in, but hopefully we get that every one of these, all 8 of them, they're all 45s. Okay, I think we probably have some examples down here. The first example, we have a rectangle and we're looking to get some measures on the lengths, okay? So we know that from rectangles that all of our diagonal pieces are congruent. So this right here is telling me that from D to E, it's 6.5. That means that I also know from B to E is also 6.5. Okay. Now this piece from A to E is also 6.5 inches. This piece from E to C is also 6.5 inches. So if I want the total distance from A to C, I can add those two together. 6.5 plus 6.5 tells me that that is 13 inches. I'm also asked to find the perimeter of ABCD. Now remember, perimeter means we have to add all the way around the outside of the shape. We know that opposite sides are the same on all of our parallelograms, including rectangles. So we can add 5 plus 12 plus 5 plus 12. I'd be like 5 plus 12 is 17. 17 plus 17 is 34. But please go ahead and use a calculator on that if you need to. Okay, next one we have DIAM is a rhombus. We're looking to find the measures of A and B and C. I'm going to start with A. I see A being the corner where our two diagonals intersect, and every single time we have a rhombus, we have a 90-degree angle because those diagonals are perpendicular. So A is 90. And I mean, we can fill in the 90 in all 4 corners if we really want to, but every one of these is a 90. Angle B, we're going to talk about how our opposite angles are the same. So this angle here is the same as this angle here. And that tells us that B will be 27. Now, because all of those are 27s, that's going to help us then figure out C, because we're going to remember our rule for triangles. The 3 angles of a triangle have to add up to 180 degrees. So I can get that angle for C down here, and in fact, all 4 of these angles will be the same value because I know 90 plus 27 plus something has to give me 180 degrees. So I can do 180, take away the 2 values that I know, and that will tell me what's left over. And again, we can add them first, and then subtract the sum from 180. Bam. Or we could take our 180 and minus each value. It should give us the same one either way. That's if I can hit the minus signs instead of the plus signs. Minus. And minus. Bam. 63 degrees for angle C. Okay, that should be it for these notes. Good luck on the exercises, and please let me know if you have any questions.